What you need to know is that an integral is the opposite of a derivative. If you have a function and you derive it, right? Let's say you have the function 3x squared, right? And you derive it, you get 6x. If this is f of x, then this is f prime of x, right? To get it back to f of x, you would integrate. And you would integrate 6x, and you would get 3x squared. This is so random, I know, that the area under the curve would be the opposite thing of a derivative. To be honest, I don't know why it works, but it just works. So an integral is the opposite of a derivative, or an anti-derivative is what it's called. So to figure out how it works and how to apply integrals, if you know that it's the opposite of a derivative, you know that when you have a function, let's say x squared, and you derive it, you get 2x, right? Because you multiply it by the exponent, and the exponent gets subtracted by 1. When you integrate something, let's say we're integrating 2x, what you do is you add 1 to the exponent, because in derivatives you subtract 1, so what you do is you add 1 to the exponent, so right now the exponent is 1, so it becomes 2x squared, and then you divide it by what your exponent is, so over 2, right? And you end up with x squared. So it's the exact opposite of a derivative. So if you have the function 6x squared, and you're trying to integrate it, what you do is you add 1 to the exponent, so you get 6x cubed, and then this new exponent, you divide it down here, because when you're deriving, you multiply, when you're integrating, you divide it. So you would end up with 2x to the third. And if you notice, if you derive 2x to the third, you get 6x squared, right? So derivatives and integrals are opposites. One more thing you need to know is that if there's no condition set here, right? And since when you derive something, any constants go away. So let's say we had the function 2x cubed plus 18, right? If we derive this, we get 6x squared, and this 18 goes away. So to compensate for that, when we integrate something and we don't know the bounds of it, this is called an indefinite integral. When we integrate something with no numbers here, just in case there was a number or a constant in your original function, you write plus c for plus constant. So it doesn't matter what this number was, but just in case there was one, you put c here. So anytime you integrate something with no bounds, no numbers that you're plugging in, you should have plus c at the end. Also, when you're deriving something, let's say you're deriving f of x equals 4x, right? And you derive it, you're going to get f prime of x equals 4. So you see that the derivative, if something is x to the first power, the x just goes away. So that means when you're integrating something, let's say you're integrating 4 dx, it's the opposite of this. So anytime you see a constant, when you're integrating, you just add an x to it. So your answer is going to be 4x plus c, right? Because there's no bounds here. So let's look at some practice problems of basic integrals, indefinite integrals. So go ahead and try this out for yourself. I'll give you a second, pause it, do it right now. All right, cool. Let's go. So first thing you do is add 1 to the exponent. So you're going to get 3x fifth, and then over whatever your new exponent is, in this case 5, plus 2x, you have to add 1 to the exponent, squared, over the new exponent is 2. And then we can simplify this more. We'll get 3x to the fifth over 5 plus x squared. And then at the end, since there's no numbers here, you have plus c. And this is going to be your integral. On the right, we have another problem. I hope you all did it too. Add 1 to the exponent, you get 4x cubed over 3, because that's a new exponent, plus x squared over 2, plus 3x, and again, plus c. Last thing we have to cover for this is the integral of sine x and the integral of cosine x. You know that when you derive sine, you get cosine. And when you derive cosine, you get negative sine. So if you're integrating it and it's the opposite, all it means is that it's the opposite, right? So if you're integrating cosine, you get sine. And if you're integrating sine, you get negative cosine, because they're just flipped. Or if you're integrating negative sine, you get cos, which you just flip it. So our integral of sine x dx is negative cosine x. And our integral for cos x dx, oh sorry, this should be plus c. And our integral for cosine x dx is just sine x. The way I remember this is just its opposites than derivatives. Because, you know, when you derive positive sine, you get positive cos. So then when you integrate positive cos, you get positive sine. That's how I remember it. Remember any way you want. But this is it for basic indefinite integrals. We're moving on to definite integrals. Definite integrals. What does that even mean? That's crazy.